A great day to one and all. Before we have the discussion, let's think of this. If the terms below form an arithmetic sequence, what number should be placed on the blank? If you have here 15, blank 45. So what number should be there? What do you think? What is your guess? And take note, if you have an arithmetic sequence, you should have a common difference, right? And if you answered 30, you are actually correct. Because if it is 30 here, if you subtract the second by the first, 30 minus 15, you get 15. 45 minus 30, you also get 15. So it seems like you have a common difference, which is 15 if the middle term is 30. So in this case, 30 is referred to as the arithmetic mean of 15 and 45. And welcome to this class and to this video. We will be talking about arithmetic means. I am Mr. Kim J.C. Ensho, a faculty member of Iloilo National High School SPSTE, and I hope that you will join me in today's discussion. This short video will zero in or focus on arithmetic means. Like if I would give you certain terms, what particular term or terms should be between them so that you could arrive to an arithmetic sequence. When we speak about arithmetic mean or means, depending on how many are required, these are term or terms between two given terms of an arithmetic sequence. So, for example, if we set a sub 1, a sub 2, a sub 3, a sub 4, a sub 5 to be a finite sequence, to be a finite arithmetic sequence, take note, by the way, that arithmetic mean or arithmetic means is only applicable for the concept of finite sequences. So from this point forward, we will be having only finite sequences, not infinite ones. So there are just limited number of terms. So in this finite sequence, the first and the last term, which is in this case, a sub 1 and a sub 5, are what we call arithmetic extremes. And all the terms between them, namely a sub 2, a sub 3, a sub 4, are what we call arithmetic means. I hope I was able to make it clear so far. So arithmetic means are the extreme ones, the first and last. Everything in between are your arithmetic means. We call this arithmetic extremes and arithmetic means because for this case, we are talking about arithmetic sequences. Now, suppose, let's have an example. Insert an arithmetic mean between 17 and 35. So, when we speak about an arithmetic mean, so our English is actually English language. Our understanding of grammar is telling us that we will insert only one arithmetic mean. So we should place one number between 17 and 35. Note that the first number being mentioned before the word end is understood to be the first term, and the number after the word end is understood to be the last term, and it should be in order for this case. So for the solution, let's have this. So between 17 and 35, we will place only one number. So we have here this number. So we don't know yet what this number is. That's why we denoted it with a sub 2. And our goal is to look for the value of a sub 2. That's why we have 17, a sub 2, 35. This means to say that your a sub 1, or the first term of this sequence, is 17. And how about 35? This is 1, 2, 3. 35 is the 35th, the third term. 35 is the third term. Sorry for that. And if you could see, how many terms do you see? You could see 3 terms, right? That is why we will set our n to be 3, because we have 3 terms. And from this, and after this, all we have to do is use again the concept of the explicit form of an arithmetic sequence, which is a sub n equals a sub 1 plus the quantity n minus 1 times d. If you don't know how to get this, if you wanted to know how this formula was derived, please feel free to check the other video, which is all about finding the terms of an arithmetic sequence. There, I discuss in detail how this formula was derived. Take note, this formula is applicable only if the sequence is arithmetic. If the sequence is not arithmetic, then don't use this formula. So we will represent, since our n is 3, we will replace all n's by 3. With that, you have a sub 3 equals a sub 1 plus the quantity 3 minus 1 times d. We don't know yet what your first and your d is, your first term and your common difference is. But simplifying for now, simplifying it gives a sub 3 equals a sub 1 plus 2d, right? And now, I think this has become clearer to you. You could see that a sub 3 here, based on the given, is 35, and a sub 1 is known to be 17. With such, by substitution, you have 35 equals 17 plus 2d. Subtracting both sides by 17, you have 8. And this means that 18 is equal to 2d. Dividing both sides by 2, we get the value of the common difference as 9. So therefore, this arithmetic sequence has a common difference of 9. And so if we go back earlier, we mentioned earlier that we have 17, and we have here our second term, let's have it as blank, and 35. And since our d is equal to 9, and we knew last time that recursively speaking, to get the next term of the sequence starting from 17, all we have to do is add the common difference. So if I have 17 plus 9, that gives us 26. And supposing if you continue the pattern, 26 plus 9, that gives us 35. So you could see here that indeed 26 makes this sequence an arithmetic sequence with a common difference of 9. And this is also telling us that indeed 26 is an arithmetic mean between 17 and 35. I hope you understand it well. Let's have another example. Insert 3 arithmetic means between 15 and negative 1. So since I mentioned 15 first, then it's understood that 15 is the first term and negative 1 is the last term. So for the solution of this, we will be putting 3 arithmetic means between 15 and negative 1. So it would look this way. And these are the 3 arithmetic means. So this means that 15 is the first term, or a sub 1 is 15. And that from here, 1, 2, 3, 4, 5, and that -1 here is a sub 5. And since we have here 5 terms in this finite sequence, then we let n be equal to 5. And since we are fully aware of the explicit formula, a sub n equals a sub 1 plus quantity n minus 1 times d, we will replace all n's by 5. With that, it gives us a sub 5 is equal to a sub 1 plus 5 minus 1 times d. So this simplifies to a sub 5 equals a sub 1 plus 4d. And what are we going to do next? You could see that a sub 5 is -1 and that a sub 1 is 15. So by substitution, we have -1 equals 15 plus 4d. Subtracting 15 both sides, you will get -16 equals 4d, and dividing both sides by 4, then you get a common difference of -4. And I believe that this negative sign is an indication that the sequence that we're looking for is in fact, that we're given is in fact decreasing, because the first term is positive, larger than your last term. So it's indeed logical to have a negative common difference. So going back here, we have 15. Then we are looking for the values of a sub 2, a sub 3, and a sub 4. And we have a -1 as well. And remember that recursively speaking, to get the next term of an arithmetic sequence, we are going to add the common difference to the immediately preceding term. So 15 plus -4 gives 11. 11 plus -4 gives 7. 7 plus -4 gives 3. And let's see if we add 3 with -4. So 3 plus -4 gives us -1. And indeed, 11, 7, and 3, these three terms will make this an arithmetic sequence as well, particularly a finite arithmetic sequence. So the three arithmetic means are 11, 7, and 3. Note, since the arithmetic means are the ones being asked, your answer should only be 11, 7, and 3. Do not include 15 and -1 anymore. I hope it's clear. All right. Let's move on to this exercise. Insert two arithmetic means between 14 and 41. Feel free to pause the video if you wish and try this. So we're going to place there 2. So let's have this. So since we are going to place here 2 numbers between them, so you could see that 14 is a sub 1. And the last number 41 here is 1, 2, 3, 4. It's the 4th term. So a sub 4 is 41. And since there are 4 elements or 4 elements or objects or numbers in this sequence, then we let n equals 4. Next, recall your explicit form of an arithmetic sequence. And we will substitute all n's or replace all n's with 4. So with such, you have a sub 4 equals a sub 1 plus the quantity 4 minus 1 times d. Or a sub 4 is equal to a sub 1 plus 3d. We know that a sub 4 is 41 and a sub 1 is 14. So with such, you have 41 equals 14 plus 3d from substitution. Subtracting both sides by 14, we get 27 equals 3d. Multiplying both sides by 1/3 or dividing both sides by 3, you get d, or a common difference of 9. So with such, that is not yet our final answer because we are looking for the arithmetic means. So we're going to determine the values of a sub 2 and a sub 3. So from here, you add the common difference. 14 plus 9, that is 23. 23 plus 9, that is 32. And if you wish, 32 plus 9, you have 41. So therefore, indeed, 23 and 32, these are the two arithmetic means that we are looking for because this resulting sequence is indeed arithmetic. So take note, your final answer here should be 23, 32, or 23 and 32. If you included 14 and 41 as your final answer, then that is incorrect because 14 and 41 are arithmetic extremes. I hope you got it. Let's have one more. Insert 5 arithmetic means between negative 16 and 20. You may pause this video, give this problem a try, and if you know the answer, you may play the video and check if you got it right. Let's have the solution. So it's understood that negative 16 is your first term and 20 is your last term. 20 is the last term because it is the last number that's mentioned and it's after the word end. And since we are going to place their 5 terms, so we have 1, 2, 3, 4, 5. So you could see that a sub 2, a sub 3, a sub 4, a sub 5, a sub 6 are missing. And we're going to determine the values of these numbers. From here, you could also see that negative 16 is a sub 1 or the first term. And how about 20? That's 1, 2, 3, 4, 5, 6, 7. A sub 7 is 20. And since you have 7 terms, or your subscript here is also 7, you let n be equal to 7 and substitute it to the explicit formula of your arithmetic sequence, of the nth term of your arithmetic sequence. From such, replacing all n's by 7, you have a sub 7 equals a sub 1 plus the quantity 7 minus 1 times d, or a sub 7 equals a sub 1 plus 6d. Replacing a sub 7 by 20 and a sub 1 by negative 16, you have 20 equals negative 16 plus 6d. Adding both sides by 16 gives 36 equals 6d. Multiplying both sides by 1/6 or dividing both sides by 6 gives you the value of the common difference, which is 6. So from here, we'll be determining now the values of these numbers, considering you have your common difference. If you go from left to right, we will add with your common difference. Negative 16 plus 6, that's negative 10. Negative 10 plus 6, that's negative 4. Negative 4 plus 6, that's 2. 2 plus 6, that's 8. 8 plus 6, that gives you 14. And if you wish, 14 plus 6, it's 20. And this is indeed an arithmetic sequence because you have a common difference all throughout. Or there's another way, if you wish. If you are going from right to left, you subtract. 20 minus 6, 14. 14 minus 6, 8. 8 minus 6, 2. 2 minus 6, negative 4. Negative 4 minus 6, negative 10. And if you see negative 10 minus 6, that's negative 16. So you may just choose which of those do you find best or you find better. But for my class, or in my case, I prefer going from left to right. But if you prefer from right to left, that's still correct, as long as you know what you are doing. Okay. And if there are questions or clarifications, please feel free to reach me. You may chat also your concerns in the comment section. And please feel free to like and subscribe in this channel. And I hope you learned something important or significant, or I'm hoping that I was able to help you for your Mathematics 10 class, particularly on this topic. Thank you very much, and a great day to one and all.